Hello everybody, this is King Tut here, and welcome to another Allegro 5 tutorial. In this tutorial, I'll explain each lines of code. So this is the code that we've used in the last two tutorials. So the second tutorial and the third tutorial, we've used this code to test out if the Allegro library is actually working. But you might wonder, what do these codes do? How do they work? Well, I'm going to be explaining to you in next slides to come. Also, I'm not going to be explaining to you guys the basic syntax, like using namespace std int main and return 0, because I've already explained it in one of my C++ tutorial where I explain all of these stuff. So if you're wondering, go check it out. It's in the card up there or in the description below. So the first three codes, these are header files. And IOStream is an internal library, so it's a library that comes with C++, and they're built into C++. Allegro 5 / Allegro H, Allegro 5 / Allegro primitives.h, or actually Allegro _ primitives.h. These two are external library, and it's part of the Allegro 5 external library. So you basically download that package from MySys. So the last tutorial and the last two tutorial, I showed you how to install Allegro 5. They don't come with C++. They actually, you actually need to install it in several ways. If you have MySys 2, it makes things a lot easier to obtain the Allegro 5 library and link it up to Cevelop. So after that, you go into int main, and then you have these two inits. The first two inside main are inits. So al _ init with the parentheses and a semicolon, it initializes Allegro 5, and you have to use this or else you're going to get undefined reference errors. And after the al init, you have al _ init _ primitives _ add-on with the parentheses and a semicolon. That initializes the ability to draw different shapes and lines. But you can't use it unless you have the Allegro 5 / Allegro primitives.h added, or else the compiler will think, well, what is this? What is this? This is not declared. We don't know what this is, where this came from. And it's also optional. If you want to draw shapes, you have to uh, include the Allegro primitives library and the add-on, or else you're going to get an error. And you're not just limited to shapes. You could draw a dot, you could draw lines, so on and so forth, and polygons, and so on and so forth. So after that, you get the Allegro display asterisk window, which is another word of saying this Allegro display pointer variable, which is equal to al _ create _ display in parentheses 500, comma 500, and ended with a semicolon. So it's a pretty much of a mouthful, but what do these things do? So this right here is a pointer variable. It's an Allegro display variable. And you might be wondering, wait, aren't there like int whatnot? Well, that might be true, but this might be either a class or type def. And type def is it's a way that you could actually customize your naming for a variable, which I might do a video on it in the C++ series. So this this is a pointer variable, and you assign it to AL create display. So this part here, this function here, allows you to create a window of your defined width and length, or probably length and width of the window. So it creates a window of 500 pixels by 500 pixels. So usually, actually, if not always, you're using pixels as a unit of measurement when you're drawing windows, shapes, and different assets, mostly image and fonts. So after that, you use AL underscore clear underscore to underscore color. And in parentheses, you have AL underscore map underscore RGB in parentheses 255, comma 0, comma 0, comma 0, and then all these closing parentheses with a semicolon on it. That's basically filling in the background of your window. So usually it's black, but you could actually make it either black, you could actually make it red, green, however you want. It's really essential because if you're moving your player or you want to transition from one screen to another, you want something to clear everything, clear all the images and shapes and fonts that are drawn onto the screen. So that's where AL clear to color function comes into play. And it's always way before you put the code before you implement the line of code that draws shapes and displays image and displays fonts. And inside the parameter, you can't just put an RGB. So what inside the parentheses, it uses RGB, which is an abbreviation for red, blue, green. It's a different type. It's a type of color palette where 0 is the minimum number and 255 is the maximum number, or the maximum value you put in. So if you put 0, 0, 0, that's black. If all the RGB values are 255, the color is white. And if you put just 255 for R and 0 for G and B, it's going to be red because R is red. And the same thing for green. You just need to put R as 0 and B as 0, but green as 255. And blue is the same thing, except R and G are zeros, and B is 255. All right, so after that, you're able to draw whatever shape you want to do. In my instance, I drew a black circle, and in the first value, or the parameter, it goes 100 to the right, and the second parameter goes 100 down. And the reason why it goes 100 down and not up, because the window doesn't follow the Cartesian coordinate that we all learned, know, and love in high school and in college if we go through the science route. So it doesn't follow the Cartesian coordinate. So the positive x goes here, and the positive y goes down here. Goes down. Instead of the positive x going to the right and the positive y going up. So after that, the third value is the radius of the circle. So it's basically how big your circle you want to make. And it's based off of the radius. So I made it 5 pixels big. And the last one is the color. So in order to use RGB, you need to, as with the previous slide for clear the color, use AL map RGB, and I made it all 0, which makes the circle black. So after you do that, you want to display on the window. So all you need to do is use the AL_flip_display. That's going to show everything, all the image, all the shapes, all the fonts onto the screen. And not just any screen, it's just going to be on that window right here. So after that, you want the window to stay there for X amount of time, which if you're going to be if you're going to do game dev, you're not going to be using you're not going to have that window be displayed for X amount of time. There's a way to have that window be on forever unless you press the X button or press escape or whatever key to close the window. And that's going to be later on in the series. Probably in the next tutorial. Alright, so, but in this case, if we want to show, if you want to show the window for X amount of time, you use AL rest, and it goes by seconds. So you put 5.0, so it's going to display for 5 seconds, and then it's going to close automatically. And then freeing up memory. So after you're done and the window closes, the memories need to be freed up, or else you're going to have a memory leak. And we don't want memory leaks. So display variable that I've mentioned earlier, that's one of them. I haven't taught you how to delete a pointer variable or delete a pointer class, and that's going to be in another video in the C++ tutorial. So to free up memory for the display variable, you do AL_destroyed_display, and then the display variable name inside the parentheses. All right. Now you know each and every lines of the code. I hope you make some sample code and whatever whatever you want to, and adjust the color and play around with the shapes, especially with the circle. Thank you so much for watching, and leave a comment, tell me what you think of the video, and I shall see you in the next one. Bye.